Hello everyone, this is my Blue Dot Technical AI Safety Project sprint submission. My project is on sign language jailbreaks and evaluations. Quick background: sign languages have complex spatial grammar. That's part of the reason why we haven't really solved sign language translation in ML. There are plenty of models that recognize poses and hand configurations, but sign languages involve simultaneity, multiple things happening at once, and current approaches don't handle that very well. But LLMs are great at handling written languages, and sign languages can be written. Back in the 1970s, Valerie Sutton created Sutton Signwriting, which is a script for writing sign languages. It captures hand shapes, movements, facial expressions, body positions, and in 2015, it was added to Unicode. That means you can input signwriting as plain text into any document, any device, and any LLMs. Let me show you a quick example. This is fingerspelling. Fingerspelling is when you spell with the sign language. So I can copy these characters and I can paste them into a plain text document. But this is just a one-dimensional example. We can also represent multidimensional signs in text. Here's the ASL sign for blue dot, blue and dot. Sunwriting is also a very complex script. There are 672 base characters and each character has many variations. There's about 37,000 possible variations. Your device already supports these characters natively. You just need a font. So if you'd like to set this project up, you can feel free to download the Google's Notice and Signwriting font. You can also download this extension called SignJect, which I created to help you to render these characters. Here's what happens when I enable this extension. You see these characters. So here's why this matters for AI safety. This is a low resource script. There's very little signwriting in LLM training data, which means that there's very little signwriting in RLHF training data. And this creates an alignment gap. In my earlier research on non-standard Unicode characters, I found that when models encounter scripts that they haven't been safely trained on, their guardrails break down. The same pattern applies here, but signwriting is a lot harder than normal non-standard Unicode characters because it's a completely different writing system with spatial grammar and contextual symbols. Now, when you give a frontier model like Cloud Opus 4.6 a little bit of context about signwriting, it can actually use these characters very well. But smaller models often hallucinate and generate gibberish. Large models are also more capable with these characters, which makes them more vulnerable. And once a model can use handwriting, there are many ways to exploit that. Let me walk through that attack surface. Fingerspelling is the simplest attack. There's just one handshape per letter, but even that comes in horizontal and vertical formats, and it extends to every sign language, Japanese sign language, or Brazilian sign language. Then there are rotated attacks. You can offset every character by one rotation, and the meaning is preserved, but it looks completely different to a parser. Then you move beyond fingerspelling into actual 2D signs. Now, this is not letter by letter encoding. This is much harder to deobfuscate because a single hand shape means different things depending on context, orientation, and position. And it gets even more creative. There are many kinds of characters, and you can use, for example, the facial characters in signwriting uh, to convey messages through Morse code blinks or other nonverbal communication cues. Facial cues, you can refer to body parts. There's many ways to go about it. You can even have tactile sign language. Here's another example: lip reading regimes. Just like how deaf people can read lips and get a vague sense of what people are saying, we can use these lip reading receipts to communicate certain messages. The point is, this isn't just one trick, it's an entire attack surface with dozens of variation. And we can't just pass our way out of this because these characters are very contextual. So I built SuBench. SuBench is for signwriting Unicode bench, and signwriting Unicode bench is a blind evaluation. There's no character mappings, no system prompts explaining what signwriting is, just raw signwriting characters fed directly to the model because we want to measure native capability, not in context learning. There's two evaluation routes. One is bad signs, the other one is good signs. Bad science is a harmful capability evaluation, and good science is a beneficial capability evaluation. Bad science has two sub-evals. Jailbreak bans is just 100 harmful queries in many domains, and Science of Life is 8 detailed queries related to biorisk capabilities. Good science, we want to test if these models can actually be used for accessibility purposes. So we test whether how well this model can recognize between these 37,000 possible signwriting character variations, and we also check if the model can understand simple phrases. Right now, models score near zero on both bad science and good science. Here's an example of a report. They don't do very well. But compare that to English baselines or standard language baselines, they actually block all harmful queries. Now, as signwriting data grows and models scale, these scores will start moving. If both scores improve together, that means we're heading in the right direction. And if one improves while the other doesn't improve, that's usually a bad sign. For example, if a model gets good at blocking harmful signwriting characters but can't use it for accessibility, they're just over refusing. So SW bench or SU bench exists to track that transition so capability doesn't outrun alignment. Now the easy fix would be to just block sign writing characters entirely, but that would stall development of sign language accessibility tools, automated translation, and even humanoid robotics that can use sign language effectively. Sign writing encodes precise configurations, body movements, and spatial positions, and it's essentially a human motor description language. The right fix is the same one that we've applied to every other language. We need to train models on sign writing properly and include sign writing in RLHF data. Teach models that harmful content is harmful regardless of the script that it's written in. The full write-up, benchmark, datasets, and tools are all linked in my Substack post. Thank you.